All right. So before we get jumping into things here today, we'll have our participation quiz. Um, the module 5 and 6 quiz and the module 7 quiz are both due by the end of the day on Sunday, as well as the other 4 participation quizzes we've had this week. Today's participation quiz and all the module 8 and module 9, which will eventually kind of get posted up here, material, which we'll cover starting today. And then next week, we'll all be due at the end of the day next Thursday, right? Because we've got our second exam next Friday. So one thing that's really important, I'll mention again, is that participation quiz that requires the lockdown browser. I also have up the module 9 reading. That's not due until we start class on Tuesday. So, you've got a little bit extra time to kind of work on that. But other than that, if you kind of want to start preparing for that exam, the second exam, the answer key and the practice problems are up there. They might even be good things to review before you take the module 5, 6, and 7 quizzes. Some additional questions, you can kind of see on there from those 2 modules. Other than that, I don't think there's anything else to kind of mention housekeeping wise. So, are there any questions for me before we just jump into material and try to kind of start working our way through module 8 to set us up so that we can have a little more time to work on the more difficult stuff, which we'll finish up on Monday. Okay. All right. So module 8 is going to focus on consumers and module 9 will focus on producers. Right? So, excuse me. We're going to start out with something that looks pretty similar to something we've already talked about, which is a budget line or a budget equation or a budget constraint. I'll kind of use those terms interchangeably. It's going to look very similar to our production possibilities curve. So when we think about a consumer and they have decisions to make between buying different goods. So we'll keep this simple as just 2 goods, right? They can buy X or Y. The total amount of money they spend on good X would be however much of good X they buy times its price. Total amount of money they spend on Y be however many units of Y they buy times its price. We're going to assume for a second that individuals or consumers are spending all of their income on these 2 goods, right? And I don't know if I'll get there today, but next class or for sure, you might think about, well, what if they save? There's a way we can model in saving here, and I'll try to kind of point that out here in just a second. So in fact, yeah, I'll do it today and make sure I don't save it for Monday. So we've got how much they're spending on each good, and we're assuming that they're spending all of their income. So this is going to represent what we call our budget line, budget constraint. And it's basically going to be all these different combinations of the goods that we could buy in order to maximize later on. What we'll talk about is total utility. Okay. So let's assume we had income of 40, price of X is 2, price of Y is 5. We can kind of plug those values in. In fact, here I gave you the income, so I might as well plug that in as well so we can kind of see what that would look like. Okay. So this would be our budget constraint. Right? So how are we going to start to draw out this budget line? And I'll make the comparison to our production possibilities curve once we have it drawn out. So if I've got my income of 40, price of good X, I think I said was 2, price of good Y was 5. Okay. If I want to think about the different combinations of good X and good Y I could purchase, X, good Y. If I was only purchasing good Y here, how much total could I afford? Well, if I've got $40 and the price of Y is 5, right? Let me make sure did I get the prices matching up? So I said the price of good, yeah, X is 2. Yeah, okay, perfect. So I could afford to buy 8 units of good Y. If I was only buying good X, how much could I afford to buy? Well, if every unit is $2, divide my income by that price, and I would see I could buy 20 units of good X. Okay. Now, my budget equation told me that I don't just have to buy one of those 2 goods. I can buy, some of one and a little bit of the other. So for us, if we think about what was our budget equation, something like this. Let's assume I wanted to buy 10 units of good X. So if I wanted to buy 10 units of good X, how much total would I be spending? Sorry, I'm trying to move this paper here. On good X. So I plug a 10 in here. Let's see, 20. So I have $20 remaining. How much of good Y could I buy? Well, there's still a little bit of algebra. I can figure out, I could buy what? 4 units. So if I'm buying 10 units of good X, I could buy 4 units of good Y, right? Spending all of my income. I could then do that for all the different quantities of X. I would find the corresponding values for Y. And what that line would represent then is the different combinations of these two goods that I could afford to buy using all of my resources or my income. What did this look very similar to? Production possibilities curves. I can produce two goods using all of my resources. Just now, we're looking not at an economy, we're looking at one consumer. Their resources are their income. We said we can also calculate the slope, right, by simply the change in Y over the change in X. That was like our production possibilities curve. So here, what would that be? Going from 8 to 0, so -8. Going from 0 to 20, so 20, we would have a slope of -0.4. Why is it negative? Well, because it reflects that when we want to buy more of good X, if I still only have the same amount of money as I buy more X, I'm going to have to stop spending money on good Y. So this will look very similar to our production possibilities curve, okay? And in fact, I'll point some other things out about this as well. So for our budget constraint, we're going to keep it simple here. It's going to end up being linear, right? So there's this trade-off between buying the two goods. So we said if I want to buy more Pepsi, I'm going to have to buy less pizza. The slope will be negative. There's trade-offs, right? If I spend my money on one good, I can't spend it on another. We're going to have the same 3 areas as we did for the production possibilities curve. So any point on the curve are points that I can afford and I've spent all of my income. I'm being, maybe I wouldn't call this production efficient. Now maybe I'd call it consumption efficient. Any point inside of my inside of my budget line is like the production possibilities curve. Any point below it, we said we were being inefficient or we're not using all of our resources. We'd have money left over. And then any point above our budget line, just like the production possibilities curve, these are all points that we can't afford or we don't have enough resources to get out to those points. Okay, so we can kind of think about, let's say I had this set up, I have this example where I've got, I'm trying to create a new image. I'm only buying PBR and flannel shirts, right? Going the hipster route. And so if I've got $200 to spend, price of PBR is 5, price of a flannel shirt is 20. How could I build this budget constraint? And then we'll talk a little bit more about some of the qualities of these budget constraints. So I'm going to assume, just for the sake of this example that we'll work through in class, that I've got flannel shirts on my x-axis and PBR here on my y-axis, okay? So I want to draw out this budget constraint, okay? So we'll have it here, but I'll kind of set it up. I'll draw it out for you by hand as well, okay? So let's say I told you we have flannel shirts on our x-axis, PBR on our y-axis, okay? Total amount of income I had was 200. Price of flannel shirts was 20. Price of PBR was 5. If I'm only buying PBR, how much total can I afford to buy? Well, in general, we would kind of think about this as I would take my income and divide it by the price of this Y good. So for us, what is our income? 200. What is the price of our Y good? 5. So here I could buy 40 cans of PBR here. What if I was thinking about if I'm only buying flannel shirts? How many could I afford to buy? Well, I would take my income and divide it by the price of that X good. Well, my X good here is flannel shirts, so I would have 200 over the price of a flannel shirt, or 20. I could buy 10. Right? I could also purchase any combination in between these two points that would be on my budget line. And we'll talk about how we determine some of those points here in a second. So if I use my quantities, this slope would be what? Change in the quantity of my Y good over the change in the quantity of my X good. So negative 40 over 10. Okay. Now, what will end up being true, kind of jump the gun a little bit on this, but since we have everything drawn in here, that slope will also represent something else. Okay. So this slope will always be what? Well, how was I finding my slope? I was taking the change in the quantity over the change of y over the change in the quantity of x. What is the change in the quantity of y always going to be? Well, it's going to start out, right, as m over the price of that y good, and then go to 0. So this minus 0 would just be this, technically negative, right, because I'm going down. I'm going to then divide that by, how was I getting this point? That was income over the price of my X good. So notice, same thing in the numerator, that cancels. A fraction over fraction, we can kind of, we would flip those. And so here we're going to see that the slope of my budget equation will always be the price of whatever's on my x-axis over the price of whatever is on my y-axis. So once again, it's kind of the reverse of quantities, right? When I'm using quantities, it's, that's what's on my x and y axis. So it's the change in the y good over the change in the x good. However, because those quantities, those extreme points are coming from the fact that I'm taking income and dividing it by prices, the slope will always end up being the relative price of these two goods. Or notice, in this case, negative 20 over 5. Sure enough, we get that same value of negative 4. Okay. So the slope of our budget equation, even if we don't know what these quantities are, it'll always be the relative prices of those two goods. Okay. And when I say relative price, it's the price of your X good over the price of your Y good. Okay. So what is that slope really reflecting? Well, you can think about it this way. If I want to get one more unit of the X good, so one more flannel shirt here, that cost me $20. How many of the Y good am I going to have to give up? Well, if each one costs me 5, to get $20, I would have to buy what? There it is. 4 less cans of PBR, right? So in this case, I would know I'd have to go from 40 to 36. And then we would kind of continue on to kind of figure out all those other points on that curve. Okay. Any questions on that before we keep moving here? Okay. So, I think coming up with these extreme points, right? If I'm only buying one of the goods, I think that hopefully isn't anything too crazy new or too difficult. But what if I want to think about points in the middle here? Well, really, to figure out if a point is on my curve, all I need to go do is go back to my original budget line, plug in those quantities with the prices and see if I'm spending all of my income. So point A here, how much money am I spending? Well, flannel shirts cost 20. So 2 times 20 is 40. PBR is 5. 25 times 5 is 125. 125 plus 40 would be 165. I'm not spending all of my income. I know that I'd be somewhere below that budget line. What about 8 and 8? Well, there, 8 times 20, 160. 5 times 8, 40. Add that together. I'm spending all of my income. I know that's going to be a point on the curve. Okay. And then what if I'm looking at what point is not affordable? $5 times $20 for each shirt is 100. 30 times 5 is 150. I'd be spending $250 at point C. So I know that has to be somewhere above my budget line or my budget curve. Okay. So any point below our curve is somewhere we could afford. On the curve, I'm spending all my money. C, I can't afford those points. Okay. Okay. So let me try to get this to go away. There we go. We're then going to think about how will income and price changes impact my budget line. So there's some intuitive results, but we'll kind of walk through the mathematics behind why as well. So what happens if income changes or the price of one of the good changes? So let's first walk through an example. Excuse me. where I've got an increase in income. Okay. So if my income goes from $200 to $300, right? If I'm only buying PBR, can I buy more or less than I was before? Well, the price hasn't changed. If I have more income, I should be able to buy more. Well, what if I'm only buying the x-axis good, flannel shirts? Well, I have more money, price is the same, I can now buy more. So if we actually, do the calculations, right? 300 over 20 is now 15. 300 over 5 would now be 60. So we should see that we have a higher, or kind of our budget constraint shifts outward. There's points here that before I could not afford. After this income change, I can now afford these points. Okay. Now the slope, if I take those quantities, you'll notice 60 over 15 still gives me that slope of -4. So the reason why is because income changes haven't impacted my prices. So the slope of my budget line will still be those relative prices. Okay. So income increases will shift our budget constraint out. Income decreases would do what? Well, I could afford to buy less, so it would like decrease or shift inward my budget line or my budget constraint. Okay. However, it's parallel shifts because the slope isn't going to change there, right? So I'll give you a little bit more support. I talked through it this way, but just to see another way of why the slope of my budget line is what it is and why income changes wouldn't change it. So if I have my budget constraint, total income, how much I'm spending on X, how much I'm spending on Y. When I've got, let's see, I want to save myself enough room, so I'm going to do this just over here, just to kind of show you. If I've got X and Y, well, really, if I've got a line, I want to write my Y, right? Y is equal to mx plus b. I want to write Y as a function of X. So I'm going to try to solve for what's on my Y-axis, the quantity of Y. So first I subtract this from both sides. I'm left with what? Income minus price of X times quantity of X is price of Y times quantity of Y. Divide both sides by the price of Y. Kind of rewrite this over here. So my quantity of Y would be income over the price of good Y minus the price of good X over the price of good Y times the quantity of good X. Well, notice the quantity of Y will start at the income, where income divided by the price of good Y is. And then as I buy more of X, it must be that the amount of Y I'm buying goes down by. How much does it go down by? Whatever that relative price of good X is. Okay. So that's where, another way of seeing where that slope comes from. So when income changes, what's that going to do? Well, it's going to change my intercept, but not my slope, right? So income increases will just shift that budget line out. Okay. All right. So we kind of walked through income changes. What if instead I've got the price of one of the goods going what, down? So if the price of flannel shirts goes down, well, if I'm buying cans of PBR, how many total can I afford to buy? The exact same amount, right? It didn't have a price change at all. But if the price of flannel shirts is lower, when I'm only buying flannel shirts, I can now afford to buy more. So with that $200 of income at $10, instead of buying 10, I can now afford to buy, instead of 10, I can now afford to buy 20. So notice when the price of a good goes down, I don't get a parallel shift out, but my income constraint or my income curve does kind of get kicked out. So in this case, it's becoming flatter, right? We'll kind of talk through this here in just a second, but I am still going to have, when prices are lower, I will have points that used to be unaffordable, I'm now able to afford, okay? Now, what's happening to the slope of my budget constraint when the price of Y goes, actually, what was this? No, the price of X goes down. Well, now, in order to get more X, I'm not going to have to sacrifice as much of good Y. So kind of notice before our slope was, here I've got the fractions, might help if I -4. And then here, my slope is -2. So notice before, in order to get one more flannel shirt, I was having to give up 4 cans of PBR. When flannel shirts are cheaper, well, now I only need $10 to get one more flannel shirt. So now I only have to give up 2 of the other good. So when the price of the X good goes down, right, it's kind of like that cost, how much of the other good I have to give up, is also going down. Okay. So here my slope will become flatter. Right? And then we'll kind of talk through these here in just a second. What if instead I had a similar example, and here we could do, I'll kind of continue running with the same example here. Let's instead assume this was our original, right? What did we have? We had that slope is negative price of my X good over the price of my Y good. Okay. If the price of flannel shirts instead goes up, what's going to happen to this fraction? Well, it'll go up. So my slope should be becoming steeper. And in fact, if the price of flannel shirts is higher, now if I'm only buying PBR, I can buy the same amount. But if I'm buying flannel shirts, I can only afford to buy less. Okay. So if the price of that extra goes up, I will get a steeper slope, right? Which also makes, when prices are higher, points that used to be actually, I wasn't even spending all of my money, now they're unaffordable. Okay. So price increases kick my kind of budget line or constraint down. When we had those price increases, it kicked it up. Okay. Now, we can see the same exact thing if we have a change in the price of the other goods. So let's say I had same kind of setup, but instead now I've got, use different colors here. Let's say, so I've got my slope is those relative prices of good X to good Y. Let's say the price of PBR goes up. What should be happening to my slope? Well, if the denominator is larger, it should be going down. Right? In fact, if I'm only buying PBR and the price is now higher, I can buy less. If I'm only buying flannel shirts, same amount. So notice what's happening to my slope. It's getting flatter when the price of PBR is going up, or it's going down, and my slope is going down. Okay. And then you could draw the same kind of thing. Probably should have used red to do the decrease, since that's what I used over here. But let's say the price of PBR is going down. Well, if this is going down, then the whole fraction will be going up. It should be that my slope is steeper. Sure enough, if PBR is cheaper, I can afford to buy more. There, I'm ending up with a steeper slope. Okay. Any questions on that before we keep moving? And hopefully it comes out a little better than what it looks like on my screen. This is green, but I realize it looks pretty similar to the black here, but right, this would be kind of my price decrease, or sorry, price increase. Here's my price decrease. Okay. So changes in prices will kind of kick that budget, the price of one good will change the slope of my budget constraint. Okay. So we'll talk through one more before we go back to the slides, which is just because we see a parallel shift doesn't necessarily mean it's a change in income. So how could I end up with a parallel shift even if income stayed the same? Right? So in this scenario, we started out, it was what? The price of flannel shirts was 20, price of PBR was 5. So we said our relative price of the X good compared to that Y good, 20 over 5, it's always downward sloping, so we have a negative sign there, was -4, representing that if I wanted to get one more flannel shirt, I had to give up 4 cans of PBR. Well, what if instead the price of a flannel shirt is 10, and the price of PBR is now 250. Well, if I'm only buying flannel shirts with the same amount of income, I can buy more. With the same amount of income, for PBR, it's now cheaper. I can also afford to buy more. So notice if the price of both goods change such that the ratio or the relative price doesn't change, I'll end up with a shift in my budget line, but no change in the slope. Because what would my slope be now? Well, it's the price of my X good over the price of my Y good. 10 over 250 is still 4, or downward sloping, so -4. So if we have simultaneous shifts in price, we could actually still end up with a parallel shift. Right? Okay, so A here would represent one of two things. Either I've got more income, or essentially what is it like having more income? So if I have the same $100 in my pocket, but the price of everything falls, it's almost like I had an increase in income, right? So an increase in income or a decrease in the price of both goods would push me up to A, right? Oops. B would represent, well, must have the same income, or, I've got the price of Y stayed the same because I can afford the same amount. But if I'm buying good X, I can now afford more. So it must be that I saw a change in the price of good X. What kind of change? Well, if I can afford to buy more, the prices must be lower. So B would be an increase in the price of good X. C represents that if I'm buying good Y, I can now afford to buy more. This would represent a decrease in the price of good Y. Okay. All right. Where are we at in time? Perfect. Okay. Any other questions on that? We'll revisit this on the participation quiz kind of towards the end of class here. Okay. So the next thing we'll start talking about, setting us up for Monday, is this idea of utility. Right? So all the word utility really means is it's the benefit from consuming something. Right? So utility is like happy. It's like sometimes you'll see it referred to as like consumer happiness, or the benefit that they receive from buying something. So, excuse me, I might use this term and refer to it as like our consumption bundles. It's just going to be the different quantities that we're buying of all goods. Now, for us, we're going to keep this simple at 2 good models. But, in practice, this might be I'm buying 2 TVs, 1 car, 100 gallons of milk, etc. Now, ours is only going to be like I'm buying 5 flannel shirts and 10 cans of PBR. Like, we're just going to keep it as a simple 2 good model. But this is the idea. We want to know what is the optimal consumption bundle. Okay. So where is this utility coming from? We're going to have a function that tells us when I purchase different quantities of these goods, how much total utility I'm going to derive, or how much total utility I will get from owning those or consuming those goods. Okay. So this utility function, generally, I'm not going to give you an actual function. I would just give it to you like in table form or in graph form. So if we have a total utility, we can kind of think about that as like a total benefit to consumers. How do people make decisions? Well, we know that we don't make just decisions based off the total. We kind of make decisions at the margin, right? Marginal cost versus marginal benefits. What are the benefits here? Utility, right? It's just really, you can think of margin utility and marginal benefits as the same thing, okay? So how did we calculate anything that was marginal? So marginal cost was the change in the total cost divided by a change in quantity. So marginal utility will be a change in the total utility from a change in the quantity. Okay. So our marginal utility will represent the additional utility we get from buying one more unit of a good. It's always, we're going to assume, at least in this case, it's always positive, right? Because if we're thinking about the decision to buy something, these problems aren't really problems if the margin utility is negative. So think about why. Even if the price was 0, if something was completely free and I'm a consumer, if the marginal benefit of it to me, what would it have to be greater than for me to buy it? Even if the price was 0, that's my marginal cost. The marginal benefit or marginal utility would have to be above 0. So anytime marginal utility would be negative, we know that even if it was free, someone's not going to buy that, right? You'd actually have to pay them to buy it, right? So we're really only going to be concerned with margin utility values that are positive, okay? So I think my animations are set off here. So I'll just delete this so we can see everything. let's just say I gave you a simple table. Here's my quantities. Here's the total utility from each one of these units. Here's my margin utility, right? So how was I coming up with these margin utility values? Well, it's just like when we were looking at costs, or if we were looking at, I think we had some like worker production examples. If I'm going from buying 10 to 15 units of this good, my total utility is going from 105 to 135. My utility is going up by 30, but I'm buying 5 additional units. So the change in total utility over the change in quantity, 30 over 5 would give me that marginal utility of 6. Okay. Now we'll notice initially, what was the margin utility of going from 0 to 5? Well, there the change in total utility is 60, the change in quantity is 5, so my marginal utility of those first 5 units is 12. As I buy more of something, this is going to sound very similar to the demand curve. What's happening to my margin utility? It's going down, right? Just like the idea of diminishing marginal benefits. As I consume more of something, right, that first car provides me a huge amount of margin utility. The second one, although it could still be large, not near as large of a margin utility as the first, or not near as large of a marginal benefit to the consumer as that first unit. So just like demand and diminishing marginal benefits, margin utility is going to be decreasing. Okay. So I can think about if I had a graph, right? And I was just like graphing out the amount of total utility at different quantity values. Notice as I have more of something, as my quantity is increasing, I have more of something, my total utility is still always going up, but it's doing so at a decreasing rate. Okay. So what's another way? I have an empty slide here to kind of think about margin utility. So if I've got all these different quantities of a good, and here I tell you the total utility. So it looks something like this, right? If I have more of something, it's always going to be providing me with higher amounts of utility. Okay? However, for every single unit, the additional utility I'm getting, or my marginal utility, for that very first unit, relatively steep slope, or that change in total utility divided by the change in quantity, will be relatively high. As I buy more of this good, what's happening to my change in total utility? It's getting flatter and flatter, or sorry, not a change in total utility, but the slope of my total utility curve is getting flatter and flatter. The change in my total utility from one additional unit of good X is going down. Margin utility simply reflects the slope of this total utility curve. Okay. Everybody with me on that before we keep moving here? Okay. All right, so let's get this stuff moved off the screen. So if the goal is to maximize utility, right? We're going to assume that's the goal of the consumer, right? They want to be as happy as possible, or they want to have the highest possible benefit. So they're going to try to maximize their total utility. If we had unlimited resources, how would I maximize total utility? Well, if I didn't have any income, what would I do? I would just buy everything that has that, high, margin utility above 0, right? Or we have like an infinite amount of every good. As long as it had a positive marginal benefit or marginal utility to the consumer, they would purchase it. The problem is no consumer has unlimited resources, right? They're going to face a budget constraint, right? So we've already talked about what are the components of that budget constraint. Well, how much income does the individual have? And what are the prices of the two goods? Okay. So if I've got income and the prices of these two goods, I know that, yeah, there's going to be some things where the margin utility is positive, but it's not greater than the price of the good. And so I'm going to kind of weigh this out, marginal cost versus marginal benefits. And we have a little bit more difficult of a decision to make. Right? So our ultimate goal, and I think we'll get there a little bit today, we'll solidify it on Monday, but we're trying to choose the combination of two goods where total utility is maximized. Okay. So remember, we said that every point, so I'll kind of match this up with what we talked about way back in module 2, when we're looking at quantities for production. And now we're just looking at quantities for consumption. So our production possibilities curve We said every point on the curve was what? Production efficient. Just like I said earlier, every point on my budget constraint, every point would be like consumer or consumption efficient. Right? But we said there is only going to be one point on that production possibilities curve that was allocatively efficient. So for our consumers, there will be one point that's allocatively efficient, or what we end up calling the consumer optimum, right? So this curve, right, our budget constraint, somewhat tells me like the cost of buying one more unit of good X. We also are going to start to think about what is the additional utility of having good X versus good Y. And knowing those marginal utilities, knowing my budget constraint, helps me identify where that allocated efficient point is. Okay. So that's where we will eventually get to is identifying that allocated efficient point. Before we do that, let's just think about what is the consumer's decision? How would they make a kind of unit by unit decision? Okay? So if I can buy two goods, now we know they can buy more than two, but let's just simplify it, right? It just gets more complicated with the math if we have more than two. Should I buy more of good X or good Y? Well, initially you might think I would choose whatever has the highest marginal utility, right? Whatever brings me the highest amount of additional happiness. Well, that would be true if the prices of the two goods were the same. However, just because something gives us a higher margin utility, if it costs 10 times as much, we might not actually want to buy that. Okay? So what we're actually going to do is not just look at margin utility, but we need to factor in prices. So what does the consumer do? Excuse me. They're going to look at the margin utility per dollar they have to spend. So if I look at the margin utility and I divide it by the price of a good, that's essentially telling me how many units of utility am I getting for every dollar I spend. Well, if I'm trying to spend optimally, I want to be putting money towards whatever is going to give me the highest additional utility, highest margin utility per dollar I'm spending. Another way of thinking about this is kind of the most bang for your buck, right? So what is the rule that consumers are going to follow? Well, we're going to maximize total utility, or sorry, the point where total utility will be maximized is where the margin utility per dollar of each good is exactly the same. And I'll kind of walk through the reasoning here in a second why, but this is going to be the result of, this is the point where when we have spent all of our income and the last unit of good X and the last unit of good Y provide the same margin utility per dollar, that will be where the consumer is spending optimally, or they've maximized their total utility. Okay, so why is this the case? Right, I'll kind of walk through the thought process behind why, and then next class I think I'll give you some further support for this. But if I think about the marginal utility per dollar that someone is spending on two goods, okay, if the margin utility per dollar they spend was greater from good X, what should that person do? Well, they should buy more of good X, right? More bang for your buck, more additional utility per dollar you're spending. But as I have more of something, what's happening to the margin utility of that good? We said as I buy more, the margin utility of the last unit is actually going to go down. So our margin utility per dollar would go down. Now that's going to continue. I can keep buying X if this is true. At a certain point, this margin utility per dollar is going to flip so that it's now higher for good Y. So now what do? Now I stop buying more of good X. I start buying more of good Y. As I buy more of good Y, the margin utility per dollar is falling until eventually it flips again. And then we kind of go back and forth deciding how much of good X and how much of good Y I'm going to buy until we've spent all of our income. Okay? So in practice, and we'll see in some of these examples, will they actually be equal at the consumer optimum? If everything was truly continuous and like we could buy infinitesimally small amounts of a good, then yes, that would be true. But with these like more simplified examples, we'll see that they're going to be very close, right? Now, I'll try to usually always set the numbers up so that they are exactly equal. But if you were to kind of try to build some of these on your own, you might see, oh, well, they're not quite the same at the consumer optimum, but they're going to be very close. Okay? So we'll walk through some examples here with some tables, all right? But before we do that, I also want to think about this paradox of value, okay? So kind of help just some more discussion about total versus margin utility. So use the example of like water versus diamonds here. You could also think about this as like gasoline and an actual house or something. So I'll use the diamond water example first, and then maybe I'll switch. So if you think about the total utility that you derive from drinking water all year round, that's going to be insanely high. The total utility you get from the consumption of diamonds, well, most of us, if we even consume a diamond every year, right, that total utility would be high, but it might not be as high as the total amount of utility we get. And you can even think of this over your lifetime that you would get from water. Okay. So why is that the case, right? Well, because we consume way more water than we do diamonds. Why do we do that? Because the margin utility of diamonds is much higher, right? It seems kind of like counterintuitive. Why wouldn't I buy the thing that has a higher margin utility? Because even though the margin utility of water is low, what's true about the price of water relative to the price of diamonds? Water is essentially free, right? So, I might be thinking about even, oh, hold on, sorry, I'm accidentally scrolling. Even if you're thinking about like bottled water or how much you pay for tap water, that's a really low price. So even though the margin utility of water is low, so is its price. And that's what we're using to make this, decision-making process is the margin utility per dollar we spend. So for diamonds, even though that margin utility per diamonds is high, if the price is really high, so even if the margin utility of diamond, let's say the margin utility in the price of a bottle of water was 1. So 1/1 is 1. Margin utility per dollar is 1. Just easy. If the margin utility you get from having a diamond is, $5,000, well, okay, that's the margin utility, but what if it cost you 10,000? Well, now the margin utility per dollar you spend, you're getting is only what, 0.5? And so there you would actually consume water first before you consume diamonds. Okay. So this is kind of this paradox of value that things can have a higher total utility, even though they have relatively small marginal utilities. And the reason why is because that must mean they also have a relatively low price. Okay. And you think about, so why is the total utility of water so much higher? Because you buy a lot of it. Even though the margin utility is low, you're multiplying that by the quantity you buy, it could be insanely high. Okay. So we're going to walk through kind of these simple too good model with prices and income and thinking about how consumers would make these optimal consumption decisions. Okay. So if we had this set up, and I'll kind of write this out for us. I'm going to flip this. So we've got quantity, and I need to pull this up at least so that I can see it to write these down. So you got the quantity of chips. So 0, 1, 2, 3, 4, 5, 6, 7. You got the total utility margin utility from chips. So this is what, 18, and then falls by 3 every time. I'm going to leave some space. We've got the quantity of soda. 1, 2, 3, 4, 5, 6, 7. Margin utility from soda starts at 12, falls by 2. Okay. And we're told the price of a bag of chips is $1. Price of a soda is $2. Okay. So the columns that I would need to build for myself in order to make this optimal decision, right, for the consumer, is we know that they should be comparing the margin utility per dollar they're spending on both goods, right? So if I have a quantity of 0, that doesn't really exist, right? Not buying any, I have no margin utility. At that first bag of chips, what's the margin utility per dollar? Well, this is an easy one. If the price is 1, every margin utility divided by 1 would simply be itself, All right, so we can kind of build this column out pretty quick. Over here, what's the margin utility per dollar for soda? Well, there I'm dividing it by the price of 2. So everything gets divided by 2 over here. My margin utility per dollar over here, I could also calculate. So when I'm making this decision, and I think I said I've got a total income of $12. Okay? So what's I've got $12 to spend. What's the first thing I'm going to buy? Well, the margin utility of the first bag of chips is 18 per dollar. Margin utility per dollar of the first can of soda is only 6. I'm going to buy that first bag of chips. Okay. And then, okay, do I buy the second bag of chips or the first soda? All right, well, 15 is greater than 6, so I buy the second bag of chips. Do I buy the third bag of chips or the first soda? 12 is still greater than 6. Fourth bag of chips or the first soda, 9 is still greater than 6. How much have I spent up to this point? Well, if every bag of chips is $1, I've bought 4, I've spent 4, I have $8 remaining. Okay. From here, do I buy the fifth bag of chips or the first can of soda? Well, we would say consumers at this point, if it's the exact same margin utility per dollar, they're indifferent. So we don't know which order they'll buy them in at this point. So let's assume just for a second, I'm getting kind of tired of having chips, and I say, okay, I'll buy that first can of soda. Okay. So I spent $2, I've got $6 remaining. Well, now do I buy the second soda or the fifth bag of chips? Well, now the margin utility per dollar of that fifth bag of chips is higher. Spend $1, so I'm at 5. Will I buy the second can of soda or the sixth bag of chips? 5 is greater than 3, so I buy that second soda. What about third soda or sixth bag? 4 is greater than 3, so I buy the third, spend another $2. I now have $1 remaining. So at $1 remaining, I can either buy that fourth can of soda or the sixth bag of chips, and they have the exact same margin utility per dollar. So generally, we would say that the consumer is indifferent at this point. So if they're indifferent, one thing that can make the be the tiebreaker is, can I afford that fourth can of soda? We only have $1 left. It costs $2. So if I'm indifferent between the two, but I can only afford to buy one of those goods, that's going to be the one that I choose to buy. Now I've spent all of my income on 6 bags of chips, 3 cans of soda. This should be the combination that maximizes total utility. If you want to prove that to yourself, right, you could go through, we don't have enough time, take the margin utility from each one of these, add them all up. There is no other combination of these two goods you could afford that would provide you with a higher amount of total utility. Okay. All right. Any questions before we start kind of making changes to this example here? Okay. So make a couple points here. When we had $12 of income, $2, $1 was the cost of chips and soda. Here was our optimal spending point. Right? What if instead both goods, I lowered the income to 8, but let's say both goods had the exact same price. Okay? If I have the exact same price, these examples, my life's actually a little bit easier. Because if I divide the margin utility by the price of 2 for each of these, what's going to happen to the relative size of both of these columns? Well, if I divide them by the same number, nothing. So if you have identical prices, you actually don't need to build this additional margin utility per dollar because you're spending the same amount of dollars on each good. So there I could simply look at the margin utilities. So will I buy the first bag of chips or the first can of soda? 18 is greater than 12, so I'll buy that first bag of chips. Will I buy the first can of soda or the second bag of chips? 15 is greater than 12, so I buy the second bag of chips. I've now spent what? 2 plus 2, $4. I have $4 remaining. Will I buy the third bag of chips or the fourth can of soda or first can of soda? I'm indifferent. They're the same value. So maybe I buy that third bag of chips first. I now have $2 remaining. Will I buy the fourth bag of chips or the first can of soda? 12 is greater than 9. So I buy that first can of soda. I've now spent all $8. So my optimal consumption would be 3 bags of chips and 1 can of soda. All right. So this is kind of the thought process. I kind of made the prices the same to kind of highlight if you did have the same prices, you can save yourself some work. What if instead chips were quite a bit more expensive? So just intuitively, and I think the income is a little bit different here, but relative to when we had chips being less expensive, right? If chips are now $3, soda's 1, what should happen to the optimal consumption bundle? We should see the amount of chips being purchased go down and the amount of soda actually go up. So if we run through this example, right, and I went through and found my margin utility per dollar for each one here, what would be kind of this optimal consumption? Let me see here. I forget where we're at. Okay. I'll take the time to kind of do this one here real quick. Okay. So we had quantity of chips, 0, 1, 2. Actually, save myself some time. Save you guys some time. It's the exact same quantities and the exact same margin utilities. So all I'm going to do is find the margin utility per dollar now of, well, maybe it's not as easy. Maybe I don't have as much space up here as I thought. So I will just write this out for us. So we've got quantity of chips, 0, 1, 2, 3, 4, 5, 6. That should be enough. Margin utility was 18, 15, 12, 9, 6, 3. Quantity of soda, 0, 1, 2, 3, 4, 5 should be enough. Margin utility of soda was 12, 10, 8, 6, 4. So if I want to find the margin utility per dollar we're spending on chips and the marginal utility per dollar we're spending on soda, we said the price of chips was $3, the price of soda was 1. So this becomes what? 18 over 3 is 6. 15 over 3 is 5. I would kind of continue to do that. Here the price is 1, so the margin utility per dollar remains the same. Okay. So if I'm making my decision here, what do I buy first? And I think in this example I said income starts out at $10. Will I buy that first bag of chips or the first can of soda? First can of soda. What about first bag of chips or the second soda? Second soda. Third can of soda or the first bag of chips. I've now spent what? $3. Okay. At the fourth can of soda or the first bag of chips, I'm indifferent. I've got plenty of money to spend on both. So I don't know. Let's just, for the sake of this example, say I buy that first can of soda, right? So I spent $3. Now do I buy the fourth can of soda or the second bag of chips? 6 is greater than 5, right? I spent another $1. Do I buy the fifth can of soda or the second bag of chips? 5 is greater than 4. So the optimal consumption bundle here would be 4 cans of soda, 2 bags of chips, right? So when the price of chips was higher, notice we bought quite a bit fewer chips and then more soda compared to when the price of chips was lower and the price of soda was higher. Okay. Oh, excuse me. Any questions on that before we keep moving here? Okay. So we'll take a little bit of a step back and look at this participation quiz for the day. So thinking more about the budget constraint, because on Monday's class, we are going to be combining this idea of marginal utilities with our budget constraint. Right? So our budget constraint, we said if we had 2 goods, I think this is tea and coffee here. If I told you that an individual has $200 of income, what must the price of tea be here? Well, if I know the total quantity of tea I can afford is 50 units, and I have $200 of income, what did we say? How do we determine these points? that was our total income over the price of whatever good is on that axis. So if I know the quantity from that graph was, I think it was 50. No, I can't remember. Hold on. Yes, in the first problem it was 50. And I told you that income was 200. So really you've got 200 over the price of t should give you that quantity of 50. Just a little bit of algebra. Multiply both sides by the price of t, divide both sides by 50. We would have price of t would be equal to $4. Okay. Any questions on that? Okay. So the next problem changes the numbers a little bit. So now the intercept values are 40 and 100. And I think we're told that the price of tea is instead $2. Okay. So what must the price of coffee be? Well, remember, when we have these two goods, and we had goes from 40 to 100. Excuse me, and I think I told you the price of tea was $4. Okay. Well, if I'm going from this quantity to this quantity, so I want to find the slope, that would be the change in the quantity of my y good over the change in the quantity of my x good. So the y good is going down by 40, x good is going up by 100, right? So this would be what? Negative 0.4, if I'm doing math in my head correct. What do we know the slope of this constraint is also equal to? The relative price of the x good over the price of my y good. So we know that this slope, and sorry, I forgot my negative sign, will be equal to negative 0.4. So I know that if my price of tea is not $4, that was the first example. This one was $2, correct? So how would I find the price of coffee? Well, there's negative signs on both sides. Multiply both sides by the price of tea, which was 2. That cancels. I get the price of coffee is 0.4 times 2, or what? 0.8 or $0.8 or 80 cents. Okay. So if I know the quantities and I know one of the prices, I can calculate the slope using quantities and back out what the price of the other good must be. Okay. Any questions on this one before we keep moving here? Okay. And then just talking through this one, we kind of had this in the slides, but which of the following would be true if we were looking at this graph, right? So maybe we'll do the easy ones first. What must B represent? B must represent when I'm buying X, I can afford to buy more of it, but if I'm buying Y, I can only continue to buy the same amount. That must mean I don't have more income. It must mean the price of X changed. And if I can afford to buy more of it, that must mean that the price of X went up. So that's, the price of X, sorry, I'm talking too fast. If I can afford to buy more of good X, that must mean what? The price actually is lower, right? So B wouldn't be an increase in the price of good X. It would actually represent a decrease in the price of good X. Right? Now, on the flip side, if going from the black original curve to this green line, C, if I continue, if I'm spending my money and after this change, I can still buy the same amount of good X, but I can buy more of good Y, that must mean I don't have more income. The price of X didn't change. The price of Y must have changed. If I can buy more of good Y, that must mean that the price went down. So a decrease in the price of good Y is actually what is going to cause C, right? B, we said, wouldn't be an increase in the price. Similarly, it would be a decrease in the price of good X. So only one of these is true, so we know which one, but let's just go through the others to think about this. A represents an increase in the price of X and Y. So initially, based on what we talked about earlier, you might be like, well, I know A would be an income increase, because I can buy more of both goods. But what did we say mimics an income increase? Oh yeah, that would also be if the price of both goods fell by the same proportion, right? So we still have the same relative price, but both goods are now cheaper. So the only way we would have a shift out to A or an increase in our budget line is if both goods had a price, well, I can buy more of them, so a price decrease. If both of them had a price increase, that would actually mean both of these intercepts are lower. That would look very similar to a decrease in income. So these incorrect answers, if I had a separate line drawn here that was like line D, that's what would cause line D, right? A decrease in income or an increase in the prices of both goods. Okay. Excuse me. Any questions over any of those problems? Just kind of working through some of the stuff we talked about, trying to kind of solidify some of this. Okay. So I got a little bit further with you guys in the other section, or went a little bit quicker. So what do I want to do? I introduced this idea to them as well. So I'll introduce it to you and kind of give you a foreshadowing of where we're going to be going on Monday, setting us up so we can just jump kind of right into it without having to go through as many of the terms. So we talked a lot today about this budget constraint. We then started to think about, well, yeah, I face prices, but I also like some goods more than I like others, or different goods derive different margin utilities for me. Okay. So what we're going to use next class is this thing called indifference curves. So just like a budget constraint told me the different combinations of a good, of the two goods I could afford, an indifference curve is the different combinations of the two goods that provide me the same exact amount of total utility. Okay. So if I move to different points on an indifference curve, so this might be something like I could go, we'll use my dumb chips and soda example. Maybe if I bought 3 bags of chips and 2 cans of soda, I have the same marginal utility, or not marginal, sorry, the same total utility as if I bought 2 bags of chips and 4 cans of soda. So there's going to be different combinations of these two goods. We're going to ignore prices for a second. We're not worried about how much they cost. We're just saying these are the different combinations of the two goods that would provide me with the same amount of total utility. Okay. So moving to different points on an indifference curve doesn't change total utility. It's just reflecting different combinations of the two goods that I have. So maybe this is something like, what's something I buy? Like, maybe having 5 Chipotle burritos a week and only 2 days where I eat Chick-fil-A. Maybe I view that the same as if I got, Chick-fil-A 5 days a week and Chipotle 2 days, right? It's different combinations, but it provides me the same amount of total utility. Okay. So our indifference curves, just like our budget constraint, are going to be downward sloping. And any 2 points on that indifference curve will represent the same amount of total utility. Okay. So unlike the budget constraint, our indifference curve is going to have some actual curvature to it. Okay. So we're going to be thinking about 2 different goods. At any point on that indifference curve will be a combination of those 2 goods that gives me the same amount of total utility. And they're always going to be downward sloping, reflecting that if I have to keep total utility the exact same, so let's say I'm currently consuming at point A. Well, if I want to buy more pizza, if I don't keep the total amount, or sorry, if I want to buy more pizza and I keep buying the same amount of Pepsi, what's definitely going to happen to my total utility? It's going to go up. So in order to stay on the same amount of total utility, when I buy more pizza, I would have to start giving up some Pepsi in order to keep total utility exactly the same. Okay. So we'll kind of pick up on these properties on Monday's class, just so I kind of keep the 2 different sections at the same point. I will probably go through some of this early stuff quick. So if you want to even take a glance at some of the early slides, just so that we're working through them a little quicker, because once we get to combining, well, sorry, what we're eventually going to do is combine those indifference curves with our budget constraints, and then on top of that, think about how changes in that budget constraint or income constraint will impact the consumer optimum point. So we're going to be taking what we talked about today, combine it with these indifference curves, and some of this stuff we're talking about income substitution effects gets a little bit tricky. So I want to try to have more time to kind of focus on that. So I might go through these properties. Where are they at? These 4 properties, kind of first few slides pretty quickly. Right? Okay. Let me think if there's anything else that I want to say. Just to kind of remind you, the first 4 participation quizzes from this week, so not today's, but the other 4, as well as the module 5 and 6 quiz, right? That was one module we combined, plus the 2, where is it at? Participation quizzes from that module. And then module 7's quiz, as well as the 2 participation. Those are all due the end of the day Sunday. You also have an additional assignment if you want to work ahead a little bit that isn't due until the start of class on Tuesday, which is that module 9 reading. And other than that, I think we'll end the recording here. And if you have any questions for me, I can kind of answer them.